Hi, welcome to Shivat Science Hub. Today, we'll be discussing about the first chapter of class 7, 8 and 9, that is measurement. This video covers the essential topics for those classes under the curriculum of Nepal Educational Board. Please feel free to pause the video and familiarize yourself with the information provided in this video. Before we define measurement, let's discuss why do we need to study measurement. Metrology, the study of measurement, is essential to our lives. Every day, we need to measure various things such as length, mass, time, temperature, volume, current, etc. Of course, this is not the complete list. Not just in our daily lives. Measurement is indispensable in various scientific studies. Measurement is most important to learn, discuss, and identify. In order to understand a given phenomenon, measurement of different quantity is indispensable. Accurate results about physical laws can be obtained through accurate measurements. So we need to perform experiment to understand any phenomenon in physics, and the experiment requires precise measurement. Similarly, experimental verification of laws and theories also require measurement. In fact, scientific research results are meaningless without measurement. So it's obvious that measurement is essential, and that's why we are studying it. Okay, now let's define what a measurement is and what it actually means to measure something. Literally, it means to find out the amount of something. We can find the amount by comparing it with some standard amount, which value we know. But can we measure everything? The answer is no. We cannot measure things like love, anger, hunger, etc. We call these things as non-physical quantities. Similarly, the things we can measure like the size of my shoe or my weight are called physical quantities. In the previous slide, we talked about quantity. Quantity is something we can express as how much. This may or not be the absolute amount, but also can be relative. The quantity can be measured as absolute amount or relative amount, and on this basis can be divided into different groups. Here, we shall discuss about one of the two types called physical quantity, which is measurable and can be expressed in numbers. It can further be divided into two broad types, namely fundamental, meaning foundation, and derived, meaning away from. Now let's talk about the fundamental quantity. These are quantities which do not depend on any other physical quantities. They are basic, independent, indispensable, and integral quantities. They cannot be derived from other quantities and hence cannot be further resolved into more simpler forms. There are 7 fundamental quantities as shown in the chart below. Please feel free to pause the video and familiarize yourself with the information on this chart. Note, only those highlighted are the fundamental quantities. The other part is a unit which we shall discuss later in the video. Now let's discuss the derived quantity. We begin by saying that they depend on fundamental physical quantities. They are dependent and cannot exist without fundamental physical quantities. Thus, they can only be obtained from fundamental quantities and can be further resolved into more simpler basic forms. There are several derived quantities as shown in the chart. Again, please feel free to pause the video and familiarize yourself with the information on this chart. Note, only those highlighted are the derived quantities, the other part is the unit, which we will discuss later in the video. To sum up, there are two types of quantities, namely physical, measurable, and non-physical, non-measurable quantities. Fundamental quantities can further be broadly divided into fundamental and derived quantities. The word fundamental here refers to any physical quantities because the derived quantities depend on the fundamental quantities too. Unit. Unit is an internationally accepted reference standard to measure a physical quantity. When we talk about physics, we have several physical quantities, so we need a reference to measure the physical quantity. For example, let us suppose we need to buy some groceries. How would we convey the shopkeeper what amount of specific items we need? For example, we say 10 kg of rice. Here we need a unit to identify them, and the unit is kg. In science, measurement is considered as the assignment of a numerical value to an object's physical property. Whenever we take measurements, we also have to assign unit to the numerical quantity in order to convey the relative size or magnitude of the property in questions. For instance, if I say the size of my shoe is 10, you would not actually know how long my shoes is because there being no context of what the word 10 represent. In fact, this measure would only make sense if the number 10 had a unit of measure to go along with it, like 10 inches. If you see what number that the number of unit is comparatively lesser than the number of physical quantities. Why is it so? Why the number of unit is lesser than the number of physical quantities? It's because many physical quantities can be presented by the same unit. For example, physical quantity like work and energy are two different physical quantities, but both of them are expressed by the same unit, joule. Similarly, there are many situations where many physical quantities are defined in terms of combination of existing units. For example, velocity is a physical quantity. Now the unit which is used to measure the velocity is meter per second, where meter is a unit for length and second is the unit of time. Please take a moment to read all the details. You can pause the video and understand the concepts. In order to understand the higher and lower value of a physical quantity, we use multiples and submultiples of that unit. It can sometimes happen that we can measure a certain quantity to some level and beyond and below which certain inconveniences is faced. For example, it is almost impossible to measure the distance between the sun and the farthest star in the universe in centimeter, as that would be so enormous that it could even fill a page writing the absolute value. Please feel free to pause the video and familiarize yourself with the information on the chart provided. We talked about units in the previous slides. Different countries realized the importance of unit and hence adopted their own system of units. In the world, there are three main types of system of units. They are MKS, CGS, and FPS. These acronyms are used based on the unit of measurement to measure length, mass, and time respectively. For example, in CGS system, centimeter, gram, and second are used as the fundamental units of length, mass, and time, where the first letter of centimeter C, first letter of gram G, and the first letter of second S are used. Centimeter C, gram G, second S, CGS. Similarly, to CGS system, MKS and FPS systems are defined. MKS is based on meter, kilogram, and second as the fundamental unit of length, mass, and time. And FPS is based on foot, pound, and second as the fundamental units of length, mass, and time. SI. SI is a globally accepted system for measurement. In earlier days, different parts of the world used different systems of unit according to their own convenience. So if people travel from one part of the world to another part, they faced problem communicating with each other regarding units. That's why the scientists together decided to use a globally accepted system for measurement so that everybody can use the same system for measurement. This was achieved from a general conference on weights and measure in France. The conference agreed to use MKS system as the standard system. The SI unit consists of 7 fundamental units to express fundamental quantities and 2 supplementary units to express additional fundamental quantities, which is out of the scope of your syllabus and hence not discussed in this video. The SI system is advantageous as the system proved to be rational, coherent, and extended. There are certain rules that should be followed while writing SI units. Some of the rules are given in this video. Kindly memorize the rules as they can be really helpful. Note that this is not the complete list of rules. We have already discussed fundamental quantities. The unit of this quantity are fundamental units. They are independent and cannot be derived from other units. Note, only those highlighted are the fundamental unit. The other parts are the quantities, which has already been discussed. Similarly, we have already discussed derived quantities. The unit of these quantities are called derived units. They are dependent and can be derived from fundamental unit as their product or ratios. Note, only those highlighted are the derived unit, the other part are the quantities, which have already been discussed. This part of the video is just to give you an understanding of BIPM. Any explanation to the organization is out of your syllabus and hence not discussed here. You can find out about the agency by visiting their website. This picture is from the first day of the 26th General Conference on Weights and Measure that was held from 13 to 16 November 2018. Such conferences occur every 4 years. This conference agreed to define physical quantities based on physical constant. Several definitions based on different criteria like wavelength, speed of light, platinum, iridium, bar, etc. So 1 meter is defined as the distance between two parallel gold lines which are marked on platinum iridium bar preserved as 0 degrees Celsius and 760 mm of Hg in the International Bureau of weights and measurement of Sèvres near Paris. This is a prototype of 1 meter platinum iridium bar. And here is a reference 1 meter length, open for public, and is found in a building near the BIPM. The third picture is just to illustrate that the accurate view is essential for the accurate measurement. Accordingly, we should keep our eyes straight for measuring length of an object. One kilogram. There are several definitions based on different criteria. The kilogram is the mass of a prototype cylinder of platinum iridium alloy preserved at the International Bureau of Weights and Measures at Sèvres, near Paris. This picture are the prototype of 1 kg used all over the world. It is sensitive as oil dust can alter its mass and hence kept inside the glass jar. There are several definitions for 1 second based on different criteria. For simplicity, 1 second is the 1 divided by 86400 part of the solar day. The value came from the total number of seconds in a day. So please pause the video to check the prefixes used as multiples and submultiples of a unit. This part of the video is intended for class 7, and this explains how we can measure area or volume of both regular or irregular objects. The area and volume of regular objects can be obtained from the specific formula, while it takes several approaches to measure that of irregular objects. The area of irregular objects can be obtained by graph paper method, while their volume can be obtained by displacement method. That's all on this video today. If you have any questions, please feel free to comment. And if you like my videos and if you like to encourage me to make such videos for you, kindly like, comment, share, subscribe and follow me on my Facebook, YouTube and my website. Thanks for watching. Enjoy your day.